Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 1, the Pythagorean Theorem. This series is based on content from Pearson's 12th edition by Lial, Hornsby, Schneider, and Daniels. In this chapter, we will introduce 6 trigonometric functions that will be present for the remainder of the course, and that's putting it very lightly. But first, we need to review 2 key concepts that merge algebra and geometry, the Pythagorean theorem and the distance formula. In this video, we will review the Pythagorean theorem. Now, many people can recite the Pythagorean theorem as a squared plus b squared equals c squared. You want to know my opinion on that version of it? It's garbage. Now, why would I say that? Well, because without context, this is just some algebraic statement relating 3 variables a, b, and c. It is totally void of its geometric meaning. Here's what the Pythagorean theorem really says. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining sides. So why do we say a squared plus b squared equals c squared? Well, because it's easy to remember. And in all honesty, it is correct if it's accompanied by the following picture. We have a right triangle where the hypotenuse is labeled C, the 2 legs are A and B, and we have the 90-degree angle. In this case, c squared would be equal to a squared plus b squared. The Pythagorean theorem is a tautology, which means a statement that's always true about a relationship between the 3 sides of a right triangle, the longest of which is called the hypotenuse. So if you really want to say a squared plus b squared equals c squared, you should say this. If a and b are the legs of a right triangle and c is the hypotenuse, then a squared plus b squared equals c squared. That way, it's more than algebra. It has its geometric meaning embedded in it. Notice I called the other 2 sides of the right triangle the legs. This is standard. As such, we can say the Pythagorean theorem as follows. In any right triangle, the sum of the squares of the legs equals the square of the hypotenuse, or leg squared plus leg squared equals hypotenuse squared. This is the version I prefer. It doesn't rely on having a picture, and it doesn't depend on clarifying what A, B, and C represent. And it immediately ties it to a right triangle thanks to the word hypotenuse. All right, let's try a couple of examples. On number 1, we're given legs of 7 and 24 and asked to find the hypotenuse. And number 2, we're given a hypotenuse of 14 and a leg of 10, and we need to find the other leg. For the first one, we are missing the hypotenuse, so we'll set up and solve the following equation, which is the Pythagorean theorem, using HYP for hypotenuse. 7 squared plus 24 squared equals hypotenuse squared. Square the legs. 7 squared and 24 squared are 49 and 576 respectively. Add to get 625, and then take the square root of both sides of the equation. We'll simplify the square root of 625 on the left and cancel the square on the right. And we get the hypotenuse is 25. You could argue that the solutions to this equation are both 25 and negative 25. Algebraically, that would be correct. But since this has a geometric context, we don't use the negative length for the hypotenuse. Hypotenuse is 25. For the second one, we're missing one of the legs. So we'll set up and solve the following equation, which again is just the Pythagorean theorem, using leg for the unknown leg. We have 10 squared plus leg squared equals 14 squared. Square the 10 and the 14 to get 100 and 196. And algebraically, we need to get the leg squared by itself, so we'll subtract 100 from both sides. That will leave leg squared equals 96, because 196 minus 100 is 96. And now we'll take the square root of both sides of the equation and then cancel the square on the left side. But the problem with this is that we have the square root of 96, and it doesn't simplify cleanly. If you put it in a calculator, it's approximately 9.798. We won't, though, you don't want a decimal answer to a messy square root unless you're measuring something. Here I prefer precision. So we're going to leave it as the square root of 96, except you'll be expected to simplify square roots when they can't be evaluated cleanly. It's a whole other lesson, so I'm just going to walk through how it would look here. For now, we'll just simplify it by first rewriting the 96 as 16 times 6. Then we're going to split the square root, which we can do provided it's a multiplication problem and both numbers aren't negative. And of course, the square root of 16 is 4. So the length of the missing leg is exactly 4 times the square root of 6. If we needed a decimal approximation, we would use a calculator. All right, now you try. Pause the video and try the following problems. Number 1, find the value of x, and number 2, find the value of c. Both will require the Pythagorean theorem. Make sure you know who the hypotenuse is. All right, this is your spoiler alert. If you haven't paused the video and tried them yet, beware because here come the solutions in 3, 2, 1, and go.